All right, guys. Today, what we're going to talk about is more or less definitions, uh, rules, theorems, postulates. Postulates is just a fancy term for theorem. So we're going to go over three today. This won't be as lengthy as the lecture 11. So let's go ahead and get started here. Recently, we talked about three different theorems. Complementary angles, obviously. Two angles that have to be 90 degrees. That shouldn't be. That's a definition you need to understand and be able to use. All right. And same thing for supplementary. Supplementary is when you got two angles that add up to be 180. And then lastly, you got vertical angles. You want to understand that definition. So when you got two intersecting lines, vertical angles are angles that are directly across from that intersection point, and they are congruent. So let's look at the three new terms that I want you to understand and be able to use for tomorrow. Alternate exterior angle theorem. Okay, what this says is that, let me change colors here. Let's say we have angle 1 right here. And we'll name the other angle here. In green, we'll let that be angle 2. Alternate exterior angle theorem means that we want to stay outside the parallel lines. So I'm going to write outside I'm going to write these two lines here. That means parallel, not the number 11. Parallel lines. Okay, so I am on the outside. If like you're on a train track, this is the outside part. Okay. This is outside the parallel lines. Inside would be right in through here. Okay. So what this theorem says is that alternate exterior angle theorem, okay, via this theorem, it forms two congruent angles. Okay, well, you'll see two congruent angles. Now you have to go. The reason it says alternate is you have to go across the transversal and stay on the outside. So if I was just kind of this pink line here, I'd have to go across this transversal line and get to the other side of the opposite parallel line. Those two angles are congruent. Okay? And vice versa, if I wanted to be angle 2 and I wanted to find another angle that was congruent to it on the other parallel line, go across the transversal like I did here and get outside. That's what exterior means, outside. Okay, this angle right here, let me change colors real quick, will be congruent to this angle. So that's the alternate exterior angle theorem. Now, similarly, we have the alternate interior angle theorem. Alternate means across the transversal. Interior means inside the parallel lines. Okay? And this is a symbol used for parallel lines. Looks like 11, but it's not. So let's say we have angle 2 here and angle 1 here. Now, angle 1, if I go across the transversal line there, that's this line right here, okay, go across it, and then get to that point right there, that angle right there, and you'll have a congruent angle. I don't know why I wrote 2. It should be angle 1. Okay, so that is congruent. Inside the parallel lines, inside the tracks. Okay, that's what interior means. All right, And similarly, I'm going to do the same thing with angle 2. Go across. I'm going to use my highlighter here. Go across the transversal. Get to this angle that's inside here. Okay, and that will be the other congruent angle of angle 2. If you remember, guys, quickly, vertical angles. Okay, angle 2 there, angle 2 there, and vice versa. Angle 1 and angle 1 would be here. Okay, remember, if I took that snapshot on this intersection point that's right here in the middle here, on the other parallel line with the transversal, it should be the exact same setup. Okay. Lastly, let's look at same side interior angles. Okay, interior means we're still inside the parallel lines. Okay, so it's going to look like it says inside the 11, but it's parallel lines. Okay, if I have to, I'll underline that. Well, I won't do that. Let's say we have angle 1 here. Now, same side interior angles, okay, what that means is they're not congruent. This is kind of the only one where you're not looking for congruency. You're looking for more two angles that are supplementary, okay? Now, I'm on the same side of the transversal line. That's hence the name same side interior angles. If I am inside the parallel lines and I'm on the same side of the transversal line, those two angles there are supplementary. So I'm going to write that to the side. Angle 1 plus angle 2, if they're on the same side here. And we've seen a couple questions on our daily math practice that talk about that. Those two angles should add up to be 180. All right. Like I said, keep watching, pause the video, take notes, and I'll talk to you later.